Alright, this question says to find the limit as x approaches, I think it's negative 1 of the function, okay? The limit as x approaches negative 1 of the function. So basically, when you're solving limits and we're trying to find limit of function, we need to be aware of something, situations of failures. So situational failures are situations like this, where we've got infinities divided by infinities and not divided by not. In this case, we want to try to avoid them, okay, because they don't really give us a clear value of the limits. So if you plug in your limit value inside of a denominator, and in this case, we can clearly see that plugging in one, negative 1 here would put the numerator to give a value of 0. And now that we've got a numerator of a value of 0, it's similar to the case of a 0 over 0, okay? So indeterminate form, and we won't try to avoid that. So the next thing we need to do is to further simplify the expression, and that would then make it easy for us to find the limit. So we need to further simplify this expression. Now this expression contains a complex numerator. We can clearly see that there's 1 over x plus 3 minus 1 over 2. Okay, so we can simplify that by simply multiplying these numbers by the LCM, okay, of the denominator. You multiply the top by the LCM of the denominator, and then you multiply the bottom by the LCM of the denominator. Now, let's simplify. We're going to have something such as 1 over x plus 3. That's going to be x plus 3 in here, and 2. And still with the denominator, we get 1 into x plus 3. Still with the numerator, beg your pardon. All divided by 2. And then I have my numerator, x squared minus 1. And I'm going to multiply these values by it. Alright, now this is going to cancel out. And this would also cancel out with the numerator. Then the numerator would go on to give a simple expression. We have 2 minus a parenthesis x plus 3. And then the denominator, we've got this value. Now if we look closely at that value, it can be expanded into a simple simpler form. Okay, now this is an algebraic expression we call the difference of two squares. Okay, difference of two squares, and it's expanded as such, where we've got a squared minus b squared. You're gonna have something such as a plus b and a minus b multiplied by themselves. Okay, so we will have a similar situation here, and our x squared minus 1 is going to expand to be x minus 1, x plus 1, and then we're just going to include the remaining parts of the denominator. Now, I'm going to expand this bracket to get to minus x minus 3, okay, and I have x minus 1 into x plus 1. You've got x plus 3 into 2. Now, if you further simplify the numerator, this gives negative x minus 1, and you get negative 1 and x plus 1 into x plus 3 and 2. Now, we're going to continue solving this, and if we go on to factor this back, we're going to have something such as let me make this really clear. So negative 1 into x plus 1, all divided by my value here. Okay, you can clearly see that they can cancel out here. The x plus 1 cancels, and we've got negative 1 into x minus 1 into x plus 3 and 2. Now the question, remember, it says to find the limit as x approaches negative 1. So wherever there's an x value, we've got to input a negative 1 in there. Okay, so I'm going to put a negative 1 into this expression, and we can now go on to simplify it and find the limits. Negative 1 plus 3 and 2. So we're going to have negative 1 over the negative 1 minus 1 is going to give negative 2, and we're going to have negative 1 plus 3. That's going to give 2 itself, and there's 2. So we have negative 1 on the top. We've got negative 2 times 2 times 2, negative 8. And negative cancels, and we have 1 over 8 as our answer.